Like an airplane. Because you have air in an airplane, it's not getting new air in.
It is.
It is?
Yes.
They have like a little hole?
Yeah, they have a pump.
Really?
Yeah.
So it gets it from the outside?
Yes.
Wow, I didn't know that.
And it's like the air is airplanes have it easy because essentially they're pretty leaky, but
Jesus.
so long as the air pump is working at a decent speed, they have backup pumps.
Oh.
So they have 3 pumps or 4 pumps or something, and then it exhausts through the outflow valve, and through whatever seals are not sealing quite right. Usually the door doesn't seal quite right on a plane, so there's a bit of leakage around the door, but the pumps exceed the outflow rate, and then that sets the pressure in the cabin.
Now, have you ever looked at
How it works.
planes and gone, I could fix this? I just don't have the time. Too busy making.
I have a design for a plane.
You do?
Yes.
A better design?
I mean, probably. I think it is. Yes.
Who have you talked to about this?
And I've talked to friends.
Friends?
Friends and
I'm your friend.
girlfriends. And
You can tell me. What do you got? What's going on?
Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing, meaning no need for a runway. Just shoot up straight in the air and then. Ooh. How would you do that? I mean, they do that on some military aircrafts, correct?
Yes. The trick is that you have to transition to level flight, and then the thing that you would use for vertical takeoff and landing is not suitable for high-speed flight.
So you have two different systems.
I've
Vertical
thought about
takeoff
this
and
quite a
landing
lot.
system.
I've thought about this
Okay.
quite a lot. The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low, and then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, so the propeller or turbine or whatever it is, and you've got the resistance force of the air. Now, the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
I'm too stupid for this conversation.
It makes sense, though.
No, I'm sure it does. Now, when you think about this new idea of designing, I mean, when you have this idea about improving planes,
Mm-hmm.
are you going to bring this to somebody? Or you just chuck
Well,
this
I have a lot on
around?
my plate.
Right, that's what I'm saying. I don't know how you do what you do now, but if you keep coming up with these, but it's got to be hard to pawn these off on someone else either. Hey, go do a good job with this vertical takeoff and landing system that I want to implement to regular planes.